Hello, in this video lecture series, we're going to cover chapter 2.4 in the Lock 5 textbook. This is going over box plots and comparing and looking at the relationship between quantitative and categorical variables. All right, so in this section, we're going to keep looking at one quantitative variable. And finally, we'll get to the formal rules for outliers, some formal formulas to calculate how to figure out if a data point is an outlier or not. We're going to look at box plot, another way of visualizing one quantitative variable. And then we'll look at side-by-side box plots, statistics by group, and then compare difference of means for comparing two groups and two quantitative variables. But first, let's do a quick review question. A naturalist counts the number of baby birds, or clutch size, in 130 different nests. And the information is displayed in this histogram below. The standard deviation of clutch sizes is closest to what? All right, go ahead and pause and see if you can get it correct. I'll give you a hint. You should be using the 95% rule. All right, hopefully you got 2 as the good estimate for standard deviation. So this is these types of questions are purely kind of eyeballing what 2 values give me about 95%. So I thought between about 3 and 11. So if you've said, between 3.5 or 4 to 10.5, this 3 and 11 are not exact, but I'm just trying to estimate what gives me the bulk of the data. If you think of this as like an iceberg floating up in the ocean, what is most of the iceberg? So 3 and 11. And generally, when we have a bell-shaped and symmetric distribution, like this one here, the mean will be about the center. So it looks like that's about 7, or the highest peak. So a couple ways to estimate the standard deviation is to take what's the difference between 7 and one of those lower cutoffs, 7 and 3, or 11 and 7, divide by 2. Or in the last video lesson series, I looked at the entire range going from 3 to 11, the cutoff of the 95%, find that difference and divide by 4, because that's going to be 4 standard deviations, 2 up and 2 below. Outliers can be informally identified by looking at a plot, outliers can informally be identified by looking at a plot, but one general rule of thumb for identifying outliers is data values more than 1.5 IQRs, interquartile ranges, above the quartiles. So I'm going to throw some formulas on here to get cutoffs, outlier cutoffs. But I do want to let you know that there are more than one outlier cutoffs. I've taught out of stats books that use standard deviation as one way to look at outlier cutoffs. I'm going to stick with our book's approach, and it is a fairly standard way a lot of statisticians and researchers use. The fact that if you take any number that's smaller than Q1 minus 1.5 IQRs, or any value that's larger than Q3 plus 1.5 times IQRs. And I decided I'm actually not going to go through in this lesson how to calculate these values, because we're going to do that in our next class. What we will do in this video lecture series is to look at world gross for 2011 Hollywood movies. We looked at a dot plot and a histogram in the past couple sections for this data set. We can also take a box plot. Now notice right here, this box plot is laid vertically, it's moving up, but this could just as well be laid horizontally, where the x-axis would go from 0 to 1200 from left to right. And how you read this box plot is the very center right here. That's going to be the median. So it's kind of misleading a little bit, but it looks like there's a lot more movies that are going from the median up. But in fact, it's the same number of movies are between this bottom value of 0 to the median than there are on the median to the Harry Potter movie up here. And then the other 2 ends of the box plot are Q1 and Q3. So what this box plot does is that middle box gives you the middle 50% of the data. It's right here. So there's another way to think about this. Is going to have a very strong right skew. The skew is going towards the right if we were thinking about the right going in the positive box office gross direction. Okay, the lines at the end, they're often called whiskers. These lines are whiskers. They extend from each quartile to the most extreme value that is not an outlier. So if you read this right here, one movie, or at least one movie made, let's say, $390 million. That would not be considered an outlier. Anything past this is considered an outlier. On the left side or lower end, the lower whisker, in this case, is the minimum. So this whisker is the minimum. A movie made $0. And actually, all of these are outliers. When we first looked at this data set via a dot plot in section 2. I think that was 2.2, we only estimated 3 outliers because it looked like 3 data points were farther away from the rest of the data. On the eyeball test, it looks pretty clear that these are outliers. But it turns out using the formulas from the previous slide, these formulas, calculating Q1 minus 1.5 IQR and Q3 plus 1.5 IQR, gives us all of these outliers. So maybe about a dozen or so movies would be considered outliers for the box office in 2011. Okay, let's look at another histogram. This tells us the number of hot dogs eaten at Nathan's famous hot dog eating contest between 2002 and 2015. So I want to estimate the median, estimate the IQR, and estimate the range. The median is going to be smack dab in the middle. So right here, it looks like it's about 60 hot dogs. So I'll say this is Nathan's hot dog eating contest. The median is 60 hot dogs. So just to review, that means half the contestants ate less than 60 hot dogs, and half the contestants ate more than 60. All right, the next question on here is estimate the interquartile range. All right, this estimate, we don't have exact values, but Q3 looks like it's going to be a little bit more than 65. Let's say it's 66 right here. Q3 looks like it's about 66. And then Q1 is going to be the bottom of the box. That looks like it's about, let's say, 54, less than 55. Q1 is equal to 50, what did I say, 54. So interquartile range is equal to Q3 minus Q1. So that's going to give us 66 minus 54, which would be, what, 12? Yeah, 12 hot dogs will be the interquartile range. And then estimate the range. Now I need to take the max. So I'm eyeballing here. This is 5. I'm going to estimate this to be about 70. We could probably Google and figure out the top hot dog winner, but max is 70 hot dogs. And then the min looks like actually pretty clearly exactly is 45. And the min is 45. So the range is max minus min, which that would give me 70 minus 45 to be, what is that, 25? Hot dogs would be the min. Or excuse me, would be the range. Okay, we've got another box plot here, or histogram, excuse me, comparing histograms and box plot. All right, which of the following box plots goes with this histogram for waiting times for bus? All right, so let's say, I'll put this in, it's B, and this one might not be totally clear. But if I were looking at this, I would cross off C immediately because it looks like there's a right skew. There's some values that go up larger, so that means the upper tail should be larger. Now, For A and B, both of those upper tails are larger, so A and B could work for that right skewness. But A and C also show a low outlier. A has an upper outlier and a lower outlier, but if we have a strong right skew distribution, that means an upper outlier makes sense, but there is not going to be a lower outlier. That's why B makes a lot more sense to compare with this histogram. All right, in summary, for one quantitative variable, summary statistics, we looked at mean, median, spread, standard deviation, range, IQR, and then percentiles, and then a 5-number summary. For visualization, we looked at dot plot, histogram, and then in this section, we looked at box plot. For other concepts, we want to look at the shape, symmetric, skewness or not, bell-shaped, outliers and resistance, what statistics are more resistant outliers or not, and then z-scores in the last couple sections. So what we're going to be doing a lot in this class is breaking down a quantitative variable between different categorical groups. It's actually going to be a huge interest to us, comparing different groups. Let's just do one example of that. This is a study performed in 2008, and participants were randomized to drink 5 or 6 cups of either tea or coffee every day for 2 weeks. So a random group was split up. So one group was told to drink tea, one group was told to drink coffee for 2 weeks, because both of those have caffeine, but tea only has L-theanine, which is what what they're trying to measure, or something else might be different between tea and coffee. After 2 weeks, blood samples were exposed to an antigen, and production of interferon gamma immune system response was measured. So we're looking at, okay, what immune system response was measured after the 2 weeks. So looking through, the explanatory variable is tea or coffee. So categorical explanatory variable, which of the 2 treatments were used. Response variable would be measure of this interferon gamma. This is the test of the immune system. All right, if the tea drinkers have significantly higher levels of the interferon gamma, can we conclude that drinking tea rather than coffee caused an increase in this aspect of the immune response? And if your natural tendency is to say no, I don't think you have a wrong idea. But we would say in this case, there's some evidence, I'd say, you can't say cause, but there's a strong evidence that tea rather than coffee caused an increase in this aspect of the immune system response, because this is a randomized experiment. It's a random sample, and that sample was split up randomly via the variable, the tea versus coffee. Now, it would be nice if they had a third group, a control group, that were told not to drink either, but at least they were able to control the variable somewhat. So the first thing you'd want to do if you're researching this is just look at your data. After you do the experiment and get everything back, here is 2 box plots, side-by-side box plots of the coffee versus tea and the interferon gamma responses. So without knowing any science or really anything about this data, notice right here, the bulk of the tea drinkers had a much higher response rate than the bulk of the coffee drinkers. Sure, there's a coffee drinker up here, an outlier that fits up here, but this middle line is 50%. So 50% of the tea drinkers were far above 50% of the coffee drinkers. Or I should say this again, 50% of the tea drinkers are far above about 95% of the coffee drinkers. So just from a visual aid, we could see the tea drinkers had a much higher interferon gamma response. So any of the statistics we use for quantitative variable can be looked at separately for each level of a categorical variable. In this example, it's tea versus coffee. So we could also look at the mean or average level interferon gamma by drink. Right here, tea, we had a 34.82, and coffee, we had a 17.7. So this is a statistical summary to look at the difference between the means, which will often be used when comparing quantitative groups across 2 categories. So it might be more interesting to look at, instead of the absolute values of these 2 means, but the difference between these 2 to be a 17.12 difference, T over